launch like that. Yeah. And they'll be docking tonight.
So what was it? So like we were talking a little bit about it, and some of the students knew about it, but others didn't. What's the significance of that that launch to you and to space exploration?
Yeah, since 2011, we've had to, shouldn't say we, all launches of astronauts has been to, from Moscow or from Russia in their little Soyuz capsules. So the this is now it's the second launch of humans to the space station from American soil. The first one was a demo, I think that was in May, and then this one is it's just part of the rotation now. So that gives 2 ways to get up there and 2 ways to get back home. And like I said before, the Russians were charging about $80 million for each astronaut to go up in one of their Soyuz. So this is a lot cheaper.
Wow, 80 million. So what does it cost? What did it, I guess this you don't.
I don't know, but certainly SpaceX is bringing the cost really considerably down because they're reusing things.
Yeah.
And this is the first time 4 people have been able to launch at the same time to the space station. This capsule can actually hold 7. So Elon Musk and SpaceX are looking towards going to Mars. Now, I don't think they'll use this type of capsule because you know, for 8 months, you don't want to be sitting in that capsule with 6 other people. But it is using technologies and expanding on its technologies to be able to launch something to Mars.
Yeah, and I guess with it being cheaper, I mean, there's the you know the hope of going to Mars, but I guess just having more ships going up, more ships going down, better for supplies, better for studies. Better.
Absolutely, yeah. Supplies, exactly. This one, the Cargo Dragon can hold a lot of stuff, and it's already made 22 trips to the space station. So SpaceX's have developed and have proven successful on all their launches.
Cool.
So is this a new group or the same?
Well, we got a few new people, but about 3 new people, and then a bunch of the same ones. I'll tell you how many we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 with me.
10 with you. Okay, 9 and 1. Okay, perfect. Anything else you want me to start with, or should I just go ahead?
Anyone have any questions? I guess one thing that we're looking at doing this time is, along with spending our time with you, where students want to be diving into their own type of project.
Oh, absolutely.
As well, and I was just wondering if you would be open to questions sometime, or if they could email you.
Yeah, no, just give them my email address or whatever, and I'll certainly would love to answer any questions I can.
Okay, great. And you could also be a guest. You could see what the students are doing as well.
I would love to see that also. Yes.
Oh, yeah, cool.
Okay, so I will share my screen. There we go. Need to get my pointer option. So today I thought I'd go over some of the records in astronomy, biggest, littlest, fastest, etc. So the first one is just kind of an FYI, something you can use at a Christmas party to stump your friends. What is the closest planet to Earth most of the time? And the answer is Mercury.
Oh.
So, yeah. Did y'all say Mars?
I was thinking Mars. I didn't want to say it though. I was I was thinking that was too easy.
That's right, exactly. So here we have the sun in the center and the orbits of Mercury, Venus, Earth, and Mars. And on Earth, you can see that it has a line connecting it to the closest planet as it goes around. And if you look up here, you can see that Mercury is closest to Earth about 50% of the time. Venus about 30-some percent, and Mars, let's get back up to Mars. Mars about 20% of the time. So while Mars and Earth come very close to each other, it's actually Mercury that Earth is close to. And not only Earth, but actually all the planets in the solar system will be closest to Mercury most of the time, even those ones far, far out, just because of the fact that Mercury orbits the sun so quickly. It only takes 88 days. So it's always coming in line with the planets very quickly. Speaking of planets, what is the farthest naked eye planet? And any guesses?
Neptune.
Neptune? No, not quite. It's not quite that far out. It's Uranus. I've seen it twice, actually. It's quite amazing. You have to know exactly where to look to see Uranus. It's usually a telescope or binocular object. And tonight, that's where it's going to be, right in the center of that. So this is constellation Pisces, Aries, and Cetus. So it's right about there. I've got this for about 7 o'clock. Of course, it won't change much day to day.
So you're going to be looking up tonight for it?
Well, it's going to be cloudy, so no, I will not.
And when you see it, what is it? Does it look any different than?
Just like a little star.
Yeah.
If you see it, yeah. So the best, when I saw it, it was always close to a much brighter star. And you could see that that star was kind of elongated because it was showing both. So you just have to know exactly where to look. And this is way too vague to look. You have to be pinpoint. But it's a tough object, but young eyes can see it much easier. So your class might be able to see it easier, but probably not now until the springtime, until we get some nice clear skies again. So we're starting within our solar system. So what is the most massive object in our solar system? The sun.
Yeah. The sun.
And the next massive object would be Jupiter. Together, they make up 99.9% of the mass of our solar system. So even though we have, all the other planets, all the asteroids, all the comets amounting to billions and billions of objects, most of the mass is in the sun and Jupiter. The largest moon in our solar system is Ganymede, which is right here. So here we have it compared to planets, so Earth, Venus, and Mars, then Ganymede. The next largest object is Titan, a moon of Saturn, and then we have Mercury. So there are 2 moons that are larger than Mercury. And our poor little moon here is the 5th largest moons. We have Ganymede, Callisto, and Io around Jupiter, and Titan around Saturn. And our poor little moon there.
So
yep.
To be considered a moon, you have to orbit around a planet, right?
Correct.
But some of these, like some of these moons, they have volcanism and plate tectonic activities, and like lots of behaviors like you would think of an alive planet.
That's right. Yeah, our little moon is quite dead. But for instance, Io is full of volcanoes. At least 100 volcanoes are spewing lava every day. So very active. Titan has it looks kind of hazy here because it's cloud covered in methane haze. And so it has a methane cycle like we have a water cycle. So I'll show you a little bit more about Titan in a few more slides. So we can look at very active topology, changing topology on Titan also. Okay, so the brightest object in our solar system, and I certainly don't think you would get this, is a little moon called Enceladus. It's only 500-kilometer diameter. It's a moon of Saturn, and here we can see some of Saturn's rings in the background there. But it reflects 99% of the light that hits it. So it was, even though it was small, it was discovered quite early once telescopes were refined enough because it is so bright. So that brings us to the darkest objects, and these are the asteroids. Now, this is not an actual picture of an asteroid field. It's very hard to find a picture of a dark object. So the asteroids live in between. Hold on here. Houston, where Brandy Dean has NASA's Jennifer Buckley standing by to talk about 20 years of science on the International Space Station. Brandy? Okay, let's get back here. Sorry, I had the NASA site going.
No. I was going to blame Will for having his phone on here.
Oh, no, that was my bad. Okay, so here we have the darkest object, asteroids. This is typically what is shown in movies, what the asteroid belt will look like. It is certainly not this crowded. If you were within the asteroid belt, you wouldn't even be able to see any of the asteroids because there are not that, there are thousands of asteroids, but they're spread out across a very large area. So you certainly don't see it like this. And this is why, one of the reasons it's hard to discover asteroids that might come and hit us, because they are very dark. They only, where Enceladus reflects 99% of the light, asteroids only reflect about 5%. So they're tough to track. Yesterday, I believe it was, an asteroid buzzed Earth. It came within 400 kilometers of the Pacific Ocean. And it was one that we had only just found, again, because it's so dark.
What makes it dark? Is it like the chemical composition? Is it like the carbon? Is it carbon?
Exactly. It's mostly dust covering it. So carbon dust, maybe a little silica dust, but mostly carbon. Yeah.
What about
but generally they're small.
What about the really bright one? Why was that one so bright? What was it? What's its composition? Just
which one?
We had the brightest object.
Yeah. Okay, that's a moon.
Oh, so it's just reflecting. What's its surface made of that's allowing it to be so reflective?
This is all covered in ice.
Oh.
So it's another one that has a sub-ice ocean around in the whole planet. About 5 or 10 kilometers underneath that ice is an ocean. It's another place where life might be in our solar system.
It's like Europa.
Yeah, yes. This Enceladus is much smaller than Europa, but it still does have that salty water ocean.
Cool.
Okay, so darkest object, the asteroids. The largest constellations, right now, the International Astronomical Unit recognizes 88 official constellations, and the largest one is Hydra, this one here. It's a summer constellation. This is Virgo over here. It's about 1,300 square degrees, which probably means nothing to you, But if you held your fist out at arm's length, that is about 100 degrees. So you could follow this down with 13 fists all the way down. And it is the water snake. Which brings us to the smallest constellation, and that is Equus. It's a Equus. It's a hard one to say. Equus. And it is the little horse. So here we have Pegasus, the flying horse, and Equus, the little horse. The brightest constellation, most people agree that it is Orion. Both the belt stars, Betelgeuse, Bellatrix, and Rigel are all very bright stars. Betelgeuse is, if you look at it now at night, you can actually see that it's a reddish star. So it's a red supergiant that will go supernova within the next 100,000 years. And Rigel is a blue giant, very much in its main sequence, fusing helium into hydrogen. The oldest.
Got a question here.
Oh, yep.
I missed it already. I wanted to ask how many constellations there are again. You mentioned it before.
She asked, I didn't know if you heard that. How many constellations are there?
88. 88 officially recognized constellations.
Recognized by whom?
The International Astronomical Union.
Ah.
That happened about 100 years ago. They decided to define the area of each constellation. So every star in the sky belongs to one and one only constellation.
Huh.
So the oldest dated constellations, the first pictures that we have found that we pretty sure are referencing constellations. They are Taurus and Orion. And this is a cave painting from 16,500 years ago. It found in the Lascaux caves in France. So here we can see Orion's belt, Taurus's head, and the Pleiades. There we go. So we have the Orion constellation, Taurus, and the Pleiades are part of Taurus. Now, I'm sure they knew other constellations or stories about other groupings of stars in the sky, but this is the oldest one, the oldest dated one that is definitely referring to constellations. So we're kind of northern hemisphere centric. So the Maori also tied these constellations together into a war canoe that sails the Milky Way. So again, here we have Orion and Taurus and the Pleiades. The brightest star seen from Earth, any guesses? I heard it, yep, the sun. Brightest star from Earth in the nighttime sky.
North Star?
North Star. It's amazing. A lot of people think that the North Star is one of the brightest, and it's like 20th or something in brightness. No, it's actually Sirius, the dog star. So this is the constellation Ursa Major, or the Great Dog, the big dog, and its main star is Sirius right there. And Sirius is bright because it's not only a big bright star, but it's very close. It's only 9 light years away. So that's almost the closest one, not quite. So the furthest man-made object.
Ooh, didn't we just hear back from it?
Yeah, that was the second furthest, yes.
Ah!
Heard back from Voyager 2, but it's actually Voyager 1 is a little bit further. So officially they have left our solar system, although they still haven't gone past the Kuiper Belt, which is a huge reservoir of comets, and further out the Oort cloud, which contains even more objects that are gravitationally bound to our sun. So here we have the sun here and some of the orbits. This is Pluto's orbit that's on the angle there. So this is where Voyager 1 is, about 147 astronomical units away from the sun. An astronomical unit is the distance between the Earth and the sun. So Voyager 1 is 147 times farther from the sun than the Earth.
Whoa.
And it's been traveling since 1977. So it's taken a long time to get not all that far.
So what speed would it be going? Or like would the
It is going at 61,000 kilometers an hour. I knew you were going to ask that.
61,000 kilometers per hour? Wow.
I guess off the speed thing, would it be possible to like, since there isn't really any friction in space, if you were to say, if you have a, say a rocket that has a top speed of 100 miles an hour, would you be able to hit 200 miles an hour in the rocket in space then? Like,
Could you keep increasing its speed because there's no friction?
yeah, basically that's kind of.
Is that your
Oh
question?
yeah, it doesn't have anything like that. Hold on, ICBC. Sorry about this. I was not expecting this call. I'm just gonna let it go to voicemail. It doesn't, its initial velocity came from its launch, and then it got a bit of a gravitational boost from Jupiter and Saturn. But it doesn't have any other fuel on board to, except for it's not even fuel. It's a, I believe it's a radio isotropic electrical generator that just can work its a couple of its instruments. So it doesn't have any more boost to it. It can't increase its speed any more than it is right now.
If it could
But
find
certainly-
something to go around, could it? If that was, if you know, if it had, if that was built into it, could it loop around something and generate more speed?
I don't think they can steer this thing at all, so it's just going to come up to whatever it is.
Yeah.
And to get a gravitational boost, you have to have an extremely fine-tuned trajectory towards the object.
Right.
So it's probably not going to come up against anything. Maybe aliens in the far, far distant future.
Yeah.
Okay,
So Voyager 1 was launched September 5th, 1977. Voyager 2 had been launched a few weeks ahead of that, but it was slower, so it hasn't gone quite as far yet. But Voyager 1, I mean, we can still communicate, but it takes 21 hours for a radio or light signal to get to it. So it's 21 light hours away, which works out to 22 billion kilometers.
So how come we haven't sent anything like, so that was like 1977, like that's like, you know, we're like 43 years ago.
Yep.
Yeah, like have we haven't sent anything out like this since?
Oh yeah,
Oh.
the New Horizons launched in 2009 and
Oh.
went past Pluto in 2015, and then went past Arakoth a couple years later. So it's still heading out, but it's still about here.
Oh,
It
yeah.
hasn't, yeah.
And
And the Pioneers 1 and 10 and 11 were launched before the Voyagers, but they haven't made it out this far yet either.
And so it would be kind of on the same type of mission, but with different instruments and different things, ways to send it back information.
Exactly, yes, yes. The New Horizons had cameras, so they took amazing pictures of Pluto. We thought Pluto was going to look kind of like our moon, just cratered, and yet doesn't look anything like that. It's a very active object with upwelling nitrogen lava flows sort of thing, frozen. And so there's the Pioneers, the Voyagers, New Horizons. That's probably it. Everything else has been just sent out to planets. The people who study Uranus and Neptune are really hoping that there will be another space probe sent out to them to study them more, because they have not been studied very well yet. Okay, the furthest object that we've sent that has landed on another world is the Huygens spacecraft. It's landed on Titan. Like I showed you before, Titan's got this haze around it. We've never been able to see its surface. So when Huygens went down through the haze, it got these kind of pictures. So we're looking at mountain ranges and rivers, and this was a lake. Nothing in it at the time. And it landed kind of in that lake. And this is the first picture it sent back.
Cool.
These rocks are actually water ice, but it's minus 170 degrees there. So this water ice is as strong as any granite on Earth. And we can see that they're rounded, so we know there's erosion taking place. So methane is like the water cycle. It rains methane, it fills up the lakes, and then it evaporates up and makes clouds and rains again, sort of thing. So we know these rounded surfaces, we know that this lake fills up and drains periodically. So what do you need for life? You need a liquid. Methane could be the liquid on use for life on Titan. And speaking of speed, what is the fastest spacecraft that we have ever sent? It is the Parker Solar Probe.
Oh, I thought it was the Enterprise.
Yeah, warp drive is I think we talked about that a couple weeks ago. It's not going to happen. This is Parker Solar Probe is studying the sun. It will approach to within 10 solar radii, so it'll approach to within about 7 million kilometers from the center of the sun, which is an area that has never been studied before. And at 2025, it will be at its closest approach to the sun, and it will be speeding along at 690,000 kilometers per hour, which is getting up to almost 0.1% the speed of light. So this is definitely going to be the fastest object spacecraft that we've sent. And it will, at that point, like we talked about a couple of weeks ago about special relativity and general relativity, this object and its signals will be affected by both of those. So because it's going so fast, and two, because it's very close to a large mass with large gravitational forces. So that's all in our solar system. Now moving out to our Milky Way galaxy. The most luminous star in our galaxy is one called Eta Carina. It's a stellar system. There's actually a binary star, so two stars right in the center here. Had combined luminosity of greater than 5 million times that of our sun.
Whoa.
Yeah, prodigious explosion. It's one of the stars is ending its life, so it's puffing off these layers, its outer layers. And this one is located about 7,500 light years from Earth in the constellation Carina, which is a southern constellation, so we can't see it here from our northern hemisphere. It should probably go supernova too. I'm not sure if they have a estimate on when.
So if we're in the southern hemisphere, we could see this.
You wouldn't see this, you would see a very bright star.
You'd see a very bright star.
This is, yeah, this is a telescope, probably a Hubble image of it.
Wow, cool.
The largest star in our Milky Way galaxy is one called Stephenson 218. So stars, they don't have a hard edge, so it's really hard to tell exactly where you're going to measure from. So you may find other references to other stars like VY Canis Majoris as being the largest, or at least one of the largest. But it's generally accepted that this is the very largest star in our Milky Way galaxy. Its radius, well, its size is over 2,000 times the size of our sun. So our sun is right there, if you can see it, in comparison to this, the size of this.
Oh,
So it would hold 10 billion suns of our sun. It's red because the outer layers are cool. It's only about 3,200 Kelvin. Our sun is almost 6,000 Kelvin. And it's 20,000 light years away. So when it goes supernova, we will have, it will not cause us any problems at all. It will get brighter and we'll be able to study it, but it's certainly not going to cause the Earth any problems. So that's the largest star. Now, size and mass are not equivalent. The most massive star in our Milky Way galaxy is this one right here. So this is the Heart Nebula. And it's that star right in there. It's as massive as 152 suns of our, the mass of our sun. So we use the mass and the size of our sun to compare everything pretty much to. So this is 152 solar masses large, with almost 1 million times brighter than our sun. And it's also very hot. It's at almost 40,000 Kelvin. So our sun 6,000, this one at 40,000 Kelvin. The star with the highest proper motion, which just means movement across that we can see in the sky. So not coming forward, not coming towards us or away from us, but actually moving across the sky. And that's Barnard's star. It's one of those little red dwarf stars, only about 6 light years away. So that's why we can see it move so quickly. And this is the 4th nearest star, individual star to our sun. And it has a planet around it, an exoplanet that takes about 230 days to orbit this star, and it has a mass of about 3 times the Earth. And looking at the star and the motions caused by that exoplanet, there are some perturbations that suggest a second planet might be there, but farther away from the star. So we've looked at speedy spacecraft. Now we're going to look at the speediest star in our Milky Way galaxy. It has the very impressive name S4714. It orbits Sagittarius A star, which is the black hole at the center of our Milky Way galaxy. So there's the black hole, and this red line is the orbit of the star. Comes very close to it, and it is orbiting at 24,000 kilometers a second, which is 8% the speed of light. And again, when you have things going very fast and getting very close to massive objects like a black hole, general relativity kicks in. So this orbit picture is actually of this star here, S2. That's the one we use to figure out how massive the black hole is, right here at 4 million times the mass of our sun. And when that star, you can see it doesn't get as close as the fastest star there, but when that star gets close to the black hole, the light has a harder and harder time getting away from that influence. And so it gets redder. Its frequency stretches out. It's taking more energy to get away from that black hole. So, so this is for this star, and the speediest star is much closer. So its its light would even get redder, trying to get away from the black hole.
Oh.
Yeah. So the hottest star that we know of in our Milky Way galaxy is a Wolf-Rayet star, WR102, and it is over 200,000 Kelvin. At its core, it's finished its hydrogen into helium fusion and is actually fusing helium into heavier elements. And these kind of stars have really strong winds, which is blowing out the outer layers of the star. So we get to kind of look deeper into the star, which of course is much hotter. This is a very young star, but it will supernova within the next 1,500 years. So maybe tomorrow, maybe in 1,500 years, but it's almost 30,000 light years away. So it won't affect the Earth at all.
Can we see this one with a telescope?
I'm sure you could with a telescope, yes.
Yeah.
I don't think I have it. No, I didn't have it. Okay, so the closest star to Earth is one called Proxima Centauri. It's in the Alpha Centauri system, so it's a 3-star system. And there's Alpha Centauri A and B. Those two objects orbit each other. And Proxima Centauri is inside this little red circle. It's that one right there. And it orbits those other two. So it's a very, very tiny star orbiting two other main stars. And it's just over 4 light years away. And it's just been shown to have 2 exoplanets around it. So those are the closest exoplanets to Earth, but they're still 4 light years away. So the coolest star that is not a brown dwarf. So brown dwarfs do not have quite the mass to start the helium or hydrogen fusing in their core. So they are actually very much cooler. But this star, the coolest star that we know of that's not a brown dwarf, is S-Cas. So it's the S star in Cassiopeia. It's large. It's almost 1,000 times larger than our sun, but it's very cool. It's only 1,800 Kelvin. So only, a third of the temperature of our sun. And it's about 1,500 light years away. And it's in the last stages of its evolution. And so it's actually pulsating. And every time it gets larger, the gases cool down and it gets redder. And then when it pulsates closer, it heats up again. So it's one of these stars that is very large because it's in the final stages of its evolution. So we have things called open clusters in our Milky Way galaxy, and these are clumps of stars that have all been born together. And when stars first ignite, they blow off any gas or dust that might be around them, and they form beautiful open clusters. And the closest one is, again, we're back to this trio of constellations, and it's the Hyades right here. It's sort of the face of the bull. They are 153 light years away, so very close. That makes them nice and bright too. And here we have Aldebaran, which is a red giant, obviously red in the night sky. It's just in the line of sight with this open cluster. It's not actually part of the cluster. It's only about 80 light years away. And the brightest open cluster, we're back to this group again, and it is the Pleiades. So they are very young. They're only about 100 million years old. They're about 450 light years away. They're still part of the cloud. You can see here the nebulosity is part of the initial birth cloud that they were in. And if you ever look at a Subaru car, Subaru is Japanese for seven sisters, which Pleiades are also called. So their logo been based on this open cluster. We also have something called globular clusters, which are huge spherical objects of hundreds of thousands to millions of stars. And the largest one associated with our Milky Way galaxy is Omega Centauri. It's about 150 light years across, and it contains 10 million stars. At about 16,000 light years away. Again, only seen from the southern hemisphere. It's possible that this grouping of stars was actually the core of a small dwarf galaxy that we've ingested, and we've stripped off all the other stars, but the core is still circling or orbiting the Milky Way.
So if we were in the southern hemisphere, would this be pretty easy to see?
Oh, absolutely, yes.
Yeah.
Yes. You can see it clearly. It's a fuzzy big star, but through a telescope, this is the kind of views you get.
It's weird to kind of think about it though. Like you know, we're so used to looking up at the sky that we see, and then you know, if you're paying attention and if you're down in the southern hemisphere, you're seeing different things.
Totally different things down there. Yes. So these are all called nebulas, and the brightest nebula that we can see from our Milky Way galaxy is the Tarantula Nebula, and it's in the Large Magellanic Cloud. Again, something you can only see from the southern hemisphere, and it's one of the dwarf galaxies that are orbiting the Milky Way. So there's the Large Magellanic Cloud and the Small Magellanic Cloud, which is fairly close to this. So they're about 160,000 light years away, so not part of our Milky Way, but they're orbiting it. This Tarantula Nebula is the most active starburst region known in our local group of galaxies. So this has, there we go. There's a close-up of this area here. This area alone is about 1,000 light years across. And it's estimated to have a mass of about 500,000 solar masses. So there are active star formation. You can see a little open cluster there, and there's some more in here. So lots and lots of stars are being born. And this might be a way that some of those globular clusters are formed by having one small area that just makes a lot of stars that then become gravitationally combined. So moving out into the universe. So we saw that the farthest naked eye object in our solar system was Uranus. The farthest naked eye object in the universe is M31. So this is the Andromeda Galaxy. It's the closest spiral galaxy to our Milky Way. It's 2.5 million light years away, and it's very easy to spot. Anybody can see it up on clear nights in the Andromeda constellation. You can see a little fuzzy spot, and what you're seeing with your eye is probably just the core of this galaxy. And this galaxy and the Milky Way are moving towards each other at about 250 kilometers a second. So in a couple billion years, they'll start actually interacting with each other and eventually combine into one galaxy. Now, at the heart of most galaxies is a supermassive black hole. And the biggest known black hole is called, it's a galaxy called Holmberg 15A. And it's this one right here. So here we have lots and lots of galaxies. Most of these spots are galaxies. I don't even think I see any stars from the Milky Way galaxy. So these are all galaxies. And at the center of this big cluster is Holmberg 15A. And its massive black hole is 40 billion times the mass of our sun. Yes, huge. The biggest known galaxy is one called IC 1101. Very fancy names. It means it's a catalog number from somebody's certain catalog that they've done. So our Milky Way galaxy is about 100,000 light years across. This one is about 2 million light years across and holds about 100 trillion stars. This one is about 1 billion light years away from our galaxy. So it's more than 50 times the size of the Milky Way and 100 times as massive.
Is that galaxy older than our galaxy, or
All the galaxies kind of formed at the same time. Now, something like this is called an elliptical galaxy. And again, that could be the merger of other galaxies together. Like when our Milky Way and the Andromeda galaxy merge, we'll probably form an elliptical galaxy.
right?
So while all the basic galaxies were formed about 12 billion years ago, something like this is probably a merger of several of those. And the most massive star in the universe that we know of is RMC 136A1. Again, a very fancy name. So here we have that Tarantula Nebula again. And if we zoom in on this part, we see a little open cluster there, and zooming in on that. And one of these stars is 215 times the mass of our sun. It's also one of the most luminous, at 6 million times brighter than our sun.
Wow.
215 times the mass is getting to be a point where it's about as big as stars can get. There may be, theoretically, they may be able to go up to 300 million, or 300 times the mass of our sun. After that, there's too much stuff and they just fly away on any kind of rotation. They can't hold each other together, gravitationally bound together. And the most luminous star, so even though this is the most massive, it's not necessarily the most luminous or the brightest. It's a star in M33 of the Triangulum constellation, or Triangulum galaxy within the Triangulum constellation. It's very close to Andromeda. So the Andromeda galaxy, the Triangulum galaxy, and the Milky Way are all gravitationally bound. And the star, the most luminous one, is right in somewhere in this area of this galaxy, and it's 10 million times as bright as our sun. So it's an O-type star, very massive, very young star. It'll supernova within maybe 1 to 10 million years. Certainly we'll be able to see that one when it goes off. And that is all I have for you today. So if you have any questions about any of this.
All right, gang, any, oh, you got a question, Casey? Yeah. Nice and loud so Colleen can hear you.
So the brightest moon, made of ice, but its light is, I guess, heat. So how does the ice not melt or sustain the temperatures it's absorbing?
Sorry, I didn't catch any of that.
He's asking why the brightest thing that's reflecting the sun, and it's a moon with ice on it. His
Right?
question was why isn't the sun melting the ice?
Because it's at the orbit of Saturn. So it's 9.5 astronomical units. It's 1 billion kilometers away from the sun. So there's no heat getting to it. The sun's rays are very weak at that point. And it's covered with ice. I mean,
And it's the same on Earth too, right? How we have our poles and we have like the albedo effect. It just reflects right off, right?
exactly. Yes. Yes. So it's just too far to get any heat from the sun.
Good question, Case. Any other questions, guys? Before we do, we'll do a rip around the room and people just say something that they learned or something that they thought was cool. Good question.
Yeah, what would happen if an astronaut were to go up onto the ISS with some sort of virus, like say the flu or something like that? And has that ever happened?
That a virus has got into the space station? Is that kind of the?
Yeah. Talking about, we were talking about that today. Like, okay, how do they, if COVID got up there, but then the idea of like even colds and things getting up to the space station, what is, yeah.
So astronauts are typically isolated for 2 weeks or so to see if they get sick at all. And if they were to get sick, they wouldn't be able to go up. Plus, I'm sure they got lots of COVID testing. Which really surprised me, one thing when I was watching yesterday. So when the astronauts came out of the building, they were standing apart from their family. Of course, they've been isolated and all this kind of stuff, which is great. But then once they got into the cars, their families were allowed to come up and talk face to face to them and high five them. And that really shocked me, especially with COVID right now.
Right.
That's amazing. Yeah, I'm not sure why that was allowed.
I guess, because I know of all the isolation. I was wondering if someone might be a carrier and like have it in them for more than a couple of weeks, kind of thing.
Yeah, they are put through extensive physicals right before they go, they suit up. They have to make sure that they are certainly as healthy as possible. And I'm sure with the rapid COVID tests, I'm sure they got one of those before they got the final okay.
So I guess that's never happened then before.
Not that I can think of. At the beginning of the space, actually, no. In Apollo 13, one of the guys had been exposed to measles, so he wasn't allowed to go up. So his backup went up, and his backup got sick from some other thing. So unfortunately, that happened. Yes.
Oh, question, Jared?
I read an article a while ago about a meteor that cost like 10,000 quadrillion dollars or something.
About a meteor that's worth a whole bunch of money.
Oh yeah. It's iron and nickel meteor. Yeah.
That's what it was. I was wondering what it was made of.
Said it was like 10,000 quadrillion dollars or something just crazy.
10 quadrillion. Yeah. That would be I guess what it's worth if you could get it here. I'm not sure exactly how you would mine this thing. I know they're working on ways to mine asteroids for their metals, because metals on Earth are we've kind of stripped the top parts of the Earth of all our metals. We have to go deeper and deeper. So if you can find a nickel iron asteroid, it's right there, all the metals. But the mining of it would be tricky.
Right. Casey?
Is it true? I heard a while ago that there is I guess, life form, like a bacteria or something in Mars. Is that true? Like
Was that the phosphine molecule found in the clouds of Venus?
I think so.
He's talking about some sort of a biological life found privately.
Yes. So a molecule that generally can only be made by life has been called phosphine, has been found in the clouds of Venus. Although after that paper was published, other people have been looking at the data and don't think it's as convincing. And it has not been reproduced by anybody either looking at the atmosphere of Venus. If there were to be life on Venus, that's certainly where it would be. Life on the surface would not be possible. It's 500 degrees there. There is no water at all. There's no liquid at all. So clouds would possibly be the only place where life could be. It would have originally evolved on Venus and then somehow got up to the clouds. Yeah, possible.
But as far as we know, we haven't found life anywhere else.
No.
Not even bacteria or even viruses, right?
That's probably the life we will find. The places we're looking really closely at is anywhere we can find liquid water. So liquid water has been found on Mars. We know it's on some of the moons, Europa and Enceladus. And then if you want to use liquid methane as a part of the life equation, maybe on Titan. But no, we have not found life anywhere else.
Last year in the science class, their old science class, there was a big scene of this little like cell thing on Mars, and I forget.
We'll have to check that magazine. I don't.
Do you still have all the
No.
magazines?
No, he's talking about a magazine where they thought that they had maybe found something, but no, as far as we know, there's no life hasn't been found anywhere else yet. You had a question, Chris?
I just wanted to thank you for all the information. I'm actually really into like solar systems and that type of astrological side of stuff. And I don't know why, but I thought it was really interesting that the brightest star at night was Sirius and not like the northern star. I don't know why I didn't know that. Yeah, thank you so much for your time.
Sorry, I didn't catch any of it.
She's thanking you for your time and your information, and she was surprised that Sirius was the brightest star and it wasn't the North Star. And yeah, she just really enjoyed your class today.
Oh, thank you very much.
So we'll go
The
back.
North Star is the most important star in our sky, but it is not the brightest.
We'll go to Will, then we'll go to Will, and we'll go back around the room of ways that,
Okay.
that we learned about. Or here, let me get the light so you can see it. Go ahead.
I thought it was quite interesting. Just all of the well, the one star that the one moon that reflects like sunlight and it's like crazy bright, which is super cool. I thought that was kind of interesting that it was out of like all ice, and it was like curious if maybe there's life living on that, like underneath the ice or like in the ice somewhere. That'd be kind of interesting to see. Yeah.
Excuse me. Yeah.
Cool. Jacob, where are you?
Oh, I'm over
Where are you? Get in there. Oh, there you are.
I'll come over. Skiing on that sort of planet with ice. I actually found a few things interesting. At one point, I was thinking about how what we consider is super fast is minuscule compared to the speed of light. Like you were talking about how we're almost at a fraction of 1% of the speed of light with a man-made object. And the fastest object was 8%, I believe.
Yes.
Like, what the heck? That was not expected. And then Zach actually just helped me put 2 and 2 together. So something from Harry Potter about Sirius and the
It is black,
god.
yes.
But yeah, like I think it was something else, but I can't remember.
What? Series transform into
No. I can't remember.
Hmm.
Anyway, yeah.
Cool.
I thought you might like that relativity part where this light from the star is actually reddened because it's so close to the black hole. I thought of you when I did that.
Yeah, I wasn't getting. That was not something I considered initially. How like you think light and gravity, but not you don't always think light and gravity affecting each other. So and actually changing the color of that light is not something that I expected.
Yeah, and still that's only 8% C.
Yeah.
Conrad?
I just like the showing all the comparisons of the stars.
You really liked your visuals and in the ways that you could show your comparisons.
I think visual is really important. The more ways you can do things, yes.
Newman.
Perspective and sizes. It's like we think about like even getting a sliver in your finger or atoms. It's like so small, and then yet there's these galaxies and stars which were probably like an atom to them, and just all that kind of thing is really cool with the grand perspective of things. You know, it's like really. What am I doing in here? Do I have any impact on anything? No. But also I do because it's relative to us. Yeah.
Exactly.
Hello, Jared. At the back.
Yeah, in the back.
God, I can't see anything. Can I have a minute? Is that okay?
Yeah.
Okay.
Dylan?
I found it interesting how like the biggest moon was like second, third. Sorry, found that interesting.
Just talk about the sizes of some of the moons. Okay, hello, we got a new one at the back.
Hi, I'm Lucy.
We got Lucy at the back.
Lucy.
Beautiful British accent.
I actually really like pieces on the constellations and the names and things like that, on how we build stories around these things. And yeah, even like when you're looking at like the oldest named constellations or how it was, you know, things like paintings and things like that, it was stories. Yeah, I find that really, really interesting.
Did you catch that? She's kind of talking about that she really enjoyed the constellations and how the constellations they relate back to stories.
Oh, yes, yes.
And kind of is that kind of right? And as
Like before we knew what these were or what they did, we decided what they were, and we've kept that constant now.
so before we knew what they were and what they did, we kind of made things up, and we've kind of kept that tradition now.
Yeah, every culture has stories about the sky.
Right, and our need to explain the, when we don't have an answer, we just make up things.
Well, yeah, I think it's sort of the first step to astronomy or to science is looking at things and trying to figure out what they mean or what they are. Yeah.
Cool. Jared, Ray?
Yeah. I thought it was kind of neat how it was Mercury, right? That goes closest to the Earth.
Mercury that was closest to Earth?
Yeah.
And Mars, honestly.
Yeah, most of the time, right? So if you, yeah. Wow.
And then also, did you say it was Uranus you could see from Earth?
You said you could see Uranus from Earth. The farthest one that the naked eye could see. So,
Yeah, the farthest planet, yes.
so I think he's going to be making a joke of that one.
Yeah, Uranus. It's pronounced Uranus.
Uranus. It's the farthest thing you can see from the naked eye from Earth.
Uranus. Originally called George.
I guess.
Anywho,
They're arguing about Greek gods right now, so it's good. For me, I guess that one of the big takeaways is that maybe we need to do a field trip to south of the equator, right? To
Yes.
see some different stars. But when we think about like where we look for life, for whatever reason, and we talk about all these exoplanets, I always just get mind like there's so many opportunities for life being out there because of all these exoplanets. But you don't think about even all the moons that are also there that could also potentially be life. And in my head, I kind of wonder, like, you know, with a moon as opposed to, and a moon going around a planetary body, would that somehow affect the life that would evolve there? You know, just being, you know, having, I don't know.
Oh, definitely. Like the moons of Jupiter, because they're so close, they get, and Jupiter is so big and has really radiation from its magnetic field. So while there might be life in those moons, they'd probably be very far under to keep away from the radiation. So definitely the planets would affect the
life that evolves there, right?
Yeah.
Yeah. Anyway, it's interesting to think about all the possibilities. Yeah.
The current estimate is in our Milky Way galaxy, there are 10 billion Earth-size planets around star-like suns.
And then all of those, you know, there'd be so many more moons.
Yes, exactly. Yeah.
Yeah. Wow.
Definitely life is everywhere.
Yeah.
Sometimes it's actually kind of hard to think about how to realize that this is happening now, and it's not just something on a poster board, and it's not just something your school teachers tell you about. This is somewhere off now happening, and there's things off now happening that you do not know are off happening.
I guess the evolution of things, right? The beginning and the end of things is like you can see it on a grand scale.
Mm-hmm. Yeah. Yeah.
Any other last comments, gang? Well, Colleen, thank you very much. That was yeah, definitely a lot to blew our minds again. Lots to think about.
Next week, are you doing it again?
Yeah, we're here. We'll be here, and we'd be happy if you could join us.
Seeing as we have mostly new people, is that correct?
We got three new people.
Oh, okay.
Yeah.
Just wondering what topic you would like.
Gang, any ideas, topics? Well, didn't we just recently, there was a new thing that we thought was a sign that could potentially be from aliens.
Oh, no.
Like there was like a wave or I don't know what it was, but it was like, you know how like sometimes every once in a while you'll hear like, oh, there's something out there that we don't understand, that obviously we make that jump that it could be alien life form, right?
I never make that jump.
Well, yeah, the media definitely does.
Yes,
Right?
yes.
Put out there, and then inevitably it always gets kind of, it's some kind of pulsar or something else.
Yeah, okay.
From something else. Like,
How about together presentation on things we thought were aliens?
things we thought were aliens. Does that sound interesting?
That just sounds funny.
Yeah.
That's my favorite.
I mean, if we want, we could start all the way back to the beginning of Google history and work forward when we thought we were aliens.
When we thought, yeah.
Going to different.
Any other
Flat Earth theory.
flat Earth theory?
No.
Says no.
Yes.
No, it's one of those things. It's best not even talk about it, right?
I will not talk about that.
I saw an interview where this guy was talking flat earther, and then he just goes on and
Gang, we got
starts talking about how, okay, explain to me how I think that 88 different space agencies, 13 of which can go up into outer space, plus all the millions of people employed by them, plus all the airliners and the countries, how all of them work together to like make this happen, and he just couldn't explain it away.
Yeah. Lucy, Jared, Dylan, you guys, any ideas or suggestions for potential topics? Or we got one over here from Larissa. Nice and loud.
Yeah, I thought maybe we could talk about like, you know, like astrological signs like Gemini and Sagittarius and stuff like that. Like maybe something about that. I don't know.
Like astrology?
Yeah,
Astrology.
I will not talk about astrology. It is not science.
Okay.
If you want to talk about like the mythological side of it or how it came to be or whatever.
We gonna
Casey?
So like for a little mini segment, we could do how, you know, how people were inspired to name things that we use every day, but like they were inspired by space or something to do with space. You know?
Like where the names came from?
Yeah, like the Subaru thing.
Oh, like the Subaru thing. Yeah, that was super interesting.
Yeah, that's kind of cool.
Like
isn't
how
it?
space has inspired different names that we use and symbols that we use.
I would
Yeah,
have never,
just like stuff we use every day.
I don't know. Yeah, that's a tough one. That's
It might be worth looking into SpaceX itself, considering how that is, when it comes to economical wise, looking at the company of SpaceX, considering it is a private space agency, which I don't know if that's ever happened before.
There's a couple other ones right now too.
Like the actual successful going into trying to bring people to space. It's just like how the company works, how that started, current,
Go into
like the evolution.
or like yeah, so, or just
What they're doing now.
what they're doing now. Sort of explain the SpaceX, what's annoying about them, what's
Okay. I can put
pros and cons. I know I know like there's coming from specific perspectives, there can be some cons.
Yep. Sure.
Jared, nice loud voice, man.
Super Earths?
Super Earths.
Yeah.
How about the planets?
Exoplanets.
Yeah, that kind of
Just
stuff.
exoplanets. Yeah.
Jared Collins, great stuff. I just like thinking about living on a different planet.
Yeah. He says, I just like thinking about living on a different planet.
Really a lot to think about, different planets. So yeah, how a planet will affect life on it.
Right. Right. And you think about this, yeah, everything from its tectonics to its magnetosphere to its atmosphere to it has water, like so many things affect it, right?
Gravity, yeah.
Cool.
Sure. Planets. Oh, I think I have enough things here.
Oh, yeah, more than enough.
I'll see what I can find about this kind of stuff for you.
Well, Colleen, as always, thank you very much.
Thank you.
The gang, say goodbye. Thank you. Bye. Yay.